Right. The protocol BGP is special because of the attributes that it has got. Attributes. The attributes makes this protocol special. When we know BGP attribute very well, then we can say we know BGP. So far, we have seen how to enable BGP, how to advertise network in BGP, how to get the route distributed within IBGP environment where there is more than two hops, update source, next hop, EBGP multi-hop, much more. We have seen lot of things, but they're all not really focusing on attributes of BGP. So far what we have seen is how to get routes distributed inside IBGP and EBGP, between EBGP neighbors. And we were able to ping from one autonomous system to the third autonomous system by keeping second autonomous system as a transit. What we are starting now is something more important. So now we are getting into BGP path selection. See, every routing protocol has got some metric to select a path. Based on the metric, the path with the lowest metric will always be the best. But BGP is not designed to select a path by comparing the hop counts of paths or the bandwidth and delay in the path or any other metric. BGP is designed to understand our policy in path selection, our requirement, not based on bandwidth or delay or hop count or any other metric, but based on what we want as a path, how we want our path to be, which path to be an outgoing path, which path need to be an incoming. When we have multi-homing, we may have policies. We may have policies. So depending on the policy, we want path to be selected. BGP attributes helps us to achieve selecting a path according to the policy. Now these attributes, based on the characteristics, they are classified into different categories. Well known, meaning popular. Mandatory means must. Discretionary may be present, may not be. Transitive, distributed. Non-transitive, not distributed. So attributes are coming under these different categories. Some comes under optional non-transitive, some comes under optional transitive, some comes under well-known mandatory, some comes under well-known discretionary. So we are going to understand what these things are. All the mandatory attributes are well known. All the well known are not mandatory. Petrol is mandatory, and definitely it is a well known thing for a vehicle. A mirror, a side mirror, is well known that every car will have a side mirror, but it is not mandatory. Though it is well known in every vehicles, it is discretionary. You can even manage driving without mirror, though it is a dangerous decision, but still we can manage for emergency. Without side mirror we can drive. Though it is well known, it is not a mandatory like petrol or a steering wheel. Steering wheel is important. So mandatory are always well known, but all well knowns are not mandatory. Nowadays steering wheel also becoming a discretionary one because of that auto pilot thing. Fine. Now let us get into this BGP path attributes. Try understanding first what is this well-known, mandatory, well-known, discretionary, optional, transitive, optional, non-transitive. You see well-known attributes. Those attributes that must be recognized. In all BGP running devices. And these attributes are always advertised, propagated to their neighbors. Now these well-known attributes are again in two different categories. Well-known mandatory must be present in all update messages. Well-known discretionary may be present in update messages. Okay, what does that mean? You see, if you know the example, you will know what it is. Next hop address. Next hop address. For a route to be seen in a routing table, if there is a route without next hop, can that be a route? No, that cannot be a route. Routing table, if it has got a destination network in the routing table, definitely there will be a next hop. There will be a gateway for that. There will be a next hop, next router's address. There will be a gateway. There will be a next hop. That is mandatory attribute. Next hop is one of the example of well-known mandatory attribute. Next hop. Well-known discretionary may be present. There is an attribute called local preference. We'll be seeing that in detail. But now we are trying to understand what is this well-known discretionary. Local preference attribute. Local preference is well known, but you cannot expect a local preference attribute to be advertised along with the update to an eBGP neighbor. Local preference will never be advertised to eBGP neighbor. They are only advertised within autonomous system. They are only advertised between the IBGP neighbors. within the autonomous system between the IBGP neighbors. It is well known, but not seen when it is advertised to EBGP. Local preference is an example for well-known discretionary attribute. Optional attributes, they are recognized by some implementation, but expected not to be recognized by all BGP routers. Recognized optional attribute or propagated to other neighbors based on their meaning. Let's see what it is. The next paragraph. Optional transitive attribute. See, those optional attribute, though they are optional, if it is there, it is marked as a complete update, if not, marked as partial, so that the receiving router will decide a complete one to use rather than partial one. Optional transitive attributes, if not recognized, marked as partial and propagated to other neighbors. Next, optional non-transitive attribute. Optional non-transitive attribute. Though it is an optional one, if it is not found, it will be discarded. That update will not be entertained, will not be propagated, will never be used. Such attributes are called as optional non-transitive attribute. Right? So we have these classifications, these categories: well-known, mandatory and discretionary, well-known, optional transitive, optional non-transitive. We are going to see some examples. Before that, do you have any question?
I think example will make it more clear.
Correct. Let's get it. BGP attributes like AS path, next hop, origin. These three are well-known mandatory attributes. Well-known mandatory attributes. And you know the meaning of well-known and mandatory now. If these attributes are not seen in update, those updates are not considered as an update, will be discarded. Must be seen. When a network is coming, I need to see the AS path of the network. I need to see the next hop of the network and the origin, meaning how it is introduced inside BGP. Is it advertised inside BGP using network command, or it is redistributed, or coming from old protocol called EGP? See, before BGP, there was a protocol called EGP, External Gateway Protocol, but that protocol is no more. After BGP, it vanished, just like that. So, in case if there is EGP running somewhere in one of the router, we should know that it is coming from an EGP running router. That's the origin type. EGP is the reason for this network coming. Or if someone has redistributed somewhere, We should know that the origin is because of redistribution. The reason for me learning this network is because of someone redistributed. Or if someone advertises like we did yesterday's lab using network command, we need to know that these networks are coming inside because of advertisement. Three ways in which BGP may learn routes. One, advertisement using network command. Two, someone redistributing it. Three, coming from EGP protocol. BGP's own network, internal I. EGP protocol, meaning network is coming because a EGP router advertised. Network is coming because someone redistributed it. When we advertise the network using network command in BGP, it is I. It will be shown as origin type I. When it is coming from EGP inside BGP, then it is E. It will show origin type as E. If it is redistributed somewhere from OSPF into BGP or static route into BGP or connected interface into BGP or some source into BGP, those routes will be appearing with a question mark. Now let's say one network, one neighbor is giving with I, another neighbor is giving with question mark, another neighbor is giving with E, another neighbor is giving with question mark. Question mark means what? Redistributed. Incomplete. Which one the router one should prefer? It prefers I, smaller one. I is preferred over E and E is preferred over question mark. So that's why I should know origin so that I can take a decision. Origin, next hop, and AS path. These three has got star. Star means well-known, mandatory. As I said, local preference is well-known. Even MED is well-known. But they are, especially local preference is well-known discretionary. MED is optional, though it is well-known, it is coming under optional non-transitive. It should be there, at least that 0 should be there. If not, it won't advertise. Optional, non-transitive. Discard if not recognized. Okay, so these are few attributes listed here. There are more attributes coming later. But these are the attributes that are used by us to tune to achieve the policy-based path selection. The rest of the attributes, the other attributes are dynamic. We don't tune. We don't have an opportunity or option to tune them. These are the tunable one. Okay. Now this is not the order in which the attributes are checked while deciding the path. This is just, to explain us the well-known mandatory, well-known discretionary thing. Now we are going to learn one attribute after the other to understand the difference between them, and then we will see the sequence in which attributes are verified. Attributes are checked like an access list. When a packet comes in, access list entries are read from top to bottom. When a match is found, it won't go further. Let's say we have 10 lines of access list, contains 10 lines. First line, it will check whether it is matching, no match. Second line, matching, no match. Third line, matches. That's it. It won't read the fourth line. If third line says permit, it is going to permit, because the third line matches. It won't read further the fourth to 10th line. Likewise, we have list of attributes. When an update comes, to decide best path, it runs it through the attribute list, like I did sometime back. I question mark E. When a match is found, then it takes decision, and it won't read the next line. That sequence is not this one. This is not in sequence. This is just shuffled up, just to explain what a well-known mandatory attribute. We'll see that sequence, the proper sequence, later after understanding the difference between these attributes. And this is that sequence.
Okay.
This is that sequence. Now in this, what we are trying to understand is what is local preference, what is wait, what does origin code means, which we just saw, IE question mark, and then what is AS path, then MED. We are going to learn this. These are all configurable one, but eBGP over IBGP, closest, these things are not a configurable one. But this is the sequence, this is the order. All right, now let's move back. These are the attributes we are going to learn in deep. The first one is AS path attribute. We know this very well, but we'll try to go through it again. When this network 192.168.1.0 learned here, how it will learn? It will be learning with the AS path. B will know that this network is coming from the immediate autonomous system 5500, and that autonomous system received from 64520. So B knows the exact path via which the update has come. We call this as AS path attribute. While the advertisement, this network advertisement comes inside, it comes with this AS path info, AS path attribute. I'll capture a packet when we do the lab. I'll show you these attributes. I'll open those folders and show you. These numbers also shared along with the network. So BGP updates are not simply one network and one metric like OSPF cast. Oh no, it comes with a lot of attributes. All attributes. Yeah, so it's a heavy update. One of the attribute is AS path. And AS path attribute is a well-known and mandatory attribute. Next hop attribute. This also we know. Next hop will be the address of the neighbor. For example, if I am forming neighbor using loopback, and when router B learns this network 172.16.0.0, when B learns it, the next stop will not be 10.10.3, the next stop will be 2.2.2. When B learns this network from A, it will be coming with this address because we said update source command. So according to B, the next stop will be 2.2.2.2. And according to C, it is the same 2.2.2.2 until you say next stop self here. And this is what next stop attribute. It is well known and mandatory. Is there any question?
No, Anand.
Now origin attribute. You see, there is attribute number 3 called origin. This originated is different from this. We are now learning attribute 5, not 3. I'll come to this one later. Now let us go to attribute 5, understanding attribute number 5 called origin attribute. In attribute 3 also the word originated and all coming, so you should not think that this and that is same. No, that's different. The origin attribute says how the networks were introduced, prefixes were introduced. How the prefixes were introduced into BGP. These attributes will be always sent. For example, in Perth, someone advertises and in Chicago, you will be able to say that this is not redistributed, this is advertised. How? Because through the advertisement, from one corner of the world to the other corner of the world, there are many hundreds of autonomous systems, but they all distributed this attribute when they distributed the network. So the router in Chicago knows that this is not redistributed or it is not coming from EGP, it is advertised using network command inside BGP. That's why this I. Don't get misunderstood with the word IGP. IGP here does not mean the IGP routing protocol like OSPF. It doesn't mean that here. It means internal to this BGP. BGP's own network. Right? That is why it is said all autonomous system. The origin attribute informs all autonomous system in the internet work how the prefixes were introduced into BGP. The origin attribute is well known, mandatory. So we have seen so far 3 attributes. One is AS path, which is well known, mandatory. Next hop, which is well known, mandatory. Origin, which is well known and mandatory. And I was telling you, next hop attribute will be advertised along with the prefix. Sorry, AS path. And also the next hop. And also the origin. I means using network command it is advertised, not redistributed,
Mm.
not from EGP. It's from BGP's own. See, there is another I here. That is this I. This I is IBGP learned routes. IBGP. This I is not that I. See, this is internal. This is origin code IGP. That's why they put different color to differentiate. These red ones are this one, and this black one is this one. Okay.
Why from the screenshot, wherever we have autonomous system number, weight is 0, and where it is I, the weight is different.
No. You see, we have not spoken about weight, but still I would like to explain you. You are confused with two things. It's not weight, it is local preference. You see, wherever you
No,
have
that
this I,
3 to
you have 100.
3 to no 3 to
That is
768.
different. That is origin code. That is different. That is attribute number 3. I'll come to that one later. But you compared this with I don't know why. 32768 is only in this two. But
No, not compared with I. I compared
mm,
with the weight with
mm,
this path AS number. So wherever it has only I can see the weight is 32768. If I have like the path has a different autonomous number followed by I, that doesn't have that weight 0. Even this one that has local preferences.
mm. Okay, I'll tell you the reason when we go to next attribute origin. That's origin, locally origin.
Okay.
Locally origin will have. Okay, let me say now itself. It's coming again. You see, if you have next hop 0000, what does that mean? These networks are not coming from somewhere. It is local advertised
Okay.
right on this router. So when the network is local, the next hop is 0000. That itself says it's not coming from somewhere, someone. And when it is local, and if it is also coming from someone, I need to give more importance to local than the one which is coming from beta. Beta weight is only 0, but local weight is 32768, so that local will be preferred. Weight is the very first attribute.
Highest weight.
So automatically when when the next hop, is 0000, automatically the weight will be set to 32768, so that very first attribute will be a tiebreaker, and the packets will not go to 10102. It will be look it will not go to 10102, which is the next router. It will stay inside, reaching 10100 network. Okay, so it's a nice way of deciding using your own connected network instead of going to the next router for the network that is also local. This weight is not set by us. 32768 is not set by us. When the next stop is 0000, automatically the weight will be 32768.
Okay.
Default weight is 0. Higher is preferred. Now let's move on to, okay, what is this R? R is rib failure. R means rib failure. Routing information base failure. What does that mean? It means that this network is also given by some other source with less administrative distance. The same network which BGP is giving from this next hop is also given by some other source like OSPF or static route or some other source whose administrative distance is lower than this BGP's AD. For BGP, we have two administrative distance. Do you know this?
External 120, internal 200.
Yeah, internal one is 200 and external is 120.
120? It's not 20?
20.
Oh, okay.
Local preference attribute. See, this is after weight. If there is only tie in weight, it will come to, the control will come to local preference and see whether there is some variation in local preference. If one neighbor here, if neighbor A says my local preference is 200, neighbor B says my local preference is 150, so this router C, what it will do, it will decide to exit this way. Though the AS path you see, it's a very long route here. 1, 2, 3 hops. If you go this way, it is only 1 and 2 hops. Even though the AS path is less via B, it will not go via B, it will go via A, because local preference is set by you, because your policy is to exit. Your policy is to go to this ISP, ISP A, not ISP B. You have two ISPs. You prefer to go via A. That's why you set local preference higher on this router, so that every router, not only C, every router, if you have D, every router, when you set local preference higher on router A, that information will be advertised to every IBGP routers. It will be sent to every IBGP router. So every router knows that A is the best exit. So all will forward the traffic towards A, and it takes this path. And this is the attribute checked before AS path. Before AS path. So
will they send the weight to the neighbor within the IGP?
that is coming in the next slide, but answer is no. Local preference alone is advertised to all IBGP neighbors. Weight is local to that router where it is configured. That's why weight cannot impact the whole autonomous system, whereas local preference does. That's the big difference between weight and AS local preference. If weight is also advertised, then there is no difference between weight and local preference. Local preference is for the entire autonomous system to say which is the best exit. Weight is to tell that router where you have configured the best exit.
mm,
Totally different. Yeah. So local preference by default is 100. Higher is preferred. Highest local preference value is preferred. Local preference is used to advertise to IBGP neighbor about how to leave their autonomous system. Local preference is sent to IBGP neighbor only. Local preference attribute is well known, but it's not mandatory. It is not mandatory. It's well known. Definitely, it is there in every BGP appliance. It can be from Cisco or Juniper or Huawei or Zati or Palo Alto. Every vendor who runs BGP has local preference. But if it is there, it will use. If it is not there, it will decide based on some other attribute. It's not going to say this packet is invalid, this update is invalid because it's not there. See, this local preference will not be advertised to eBGP. It won't be there in the update sent to eBGP. eBGP routers will not reject it. It will say, okay, fine, no problem. We don't need a local preference from other autonomous system. It's a well-known discretionary. Simple. MED, multi-exit discriminator. Multi-exit discriminator. MED. Multi-exit discriminator. MED. This is only needed if you have multiple exits. See, this is attribute number 6 actually. Attribute number 6, you see, prefers lowest MED. Only when there is tie in the above 5, it will come to local lowest MED. Okay. So now we are not focusing on the order sequence. I'm just telling you where it is, but we are trying to understand what is this MED. MED, multi-exit discriminator. This will not be useful in all topology, only if you have dual homing. This is dual homing. This is not multi homing. This is dual homing. Do you agree? What is
because
dual
of it
homing?
has to connect.
A has got two connection to same autonomous system.
Mm,
If it is to different autonomous system, we call it as multi homing.
mm,
This is not multi homing. This is dual homing. Now, only in dual homing scenario you will need it. That too after attribute number 5. So there is less chance of MED based path selection. Now, what is this multi-exit discriminator do? This is the attribute that is advertised to eBGP neighbor, telling the eBGP neighbor how to exit their autonomous system to reach this network. This network. If A wants to reach this network of this autonomous system, how A should exit? A should exit this way. How it is determined? Because B is saying my MED is 120, C is saying my MED is 200. Now A compares this and A says, I will go this way. Lower is preferred. So A decides the exit based on what it is receiving as an MED value from the upstream autonomous system. The impact is made here, but the configuration is made on the above autonomous system. The path with the lower MED value or most desirable. MED is used to advertise to eBGP neighbor telling how to exit their network to reach this network. MED is an optional and non-transitive. See again, MED is, if it is not there, it will not be advertised. At least 0 should be there. The default MED is 0. What is optional non-transitive? Discard if not recognized. It must be there. It should be there. At least 0 should be there. The number 0. That's why you can see MED metric 0000 everywhere. All right. Now wait. Wait is local to the router. Now, if you want router A to exit on this way, this path, this higher is preferred. Wait higher is preferred. MED lower is preferred. Wait higher is preferred. Now, you set this wait 200 for this neighbor. All the traffic will go this way. If this link fails, then only it will go this way. You understood?
Yeah.
All right. I think this is related to this page. So we'll see the attribute sequence, the order, along with this page in our next class. Oh, do you have any question on today's class?
No, Aaron.
All right.